Alright, 7th graders, today we're going to talk about just drawing 3D shapes. And in doing that, you're going to have to use your imagination a great deal. I do find these difficult, sometimes even for myself, so if you catch me making a mistake, definitely let me know. So if you look at the stack of cubes here, each time they're going to be asking you to draw the top, front, and side views. And so, this particular set of blocks is shaded nicely so that you can see each of the sections. So the top view is, if you're looking straight down, you're going to see this block and this block. And they're going to be right next to each other. I might have drawn it this way instead of up and down. The front view is going to be this block and this block, and it looks like two stacked on top of each other. And then the side view is this whole piece right here, 3 blocks in an L shape right there. So if we were to do that to B, C, and D, the top view is here, here, and here. So I would draw it just how you see it. There's that block, and that block. The front view, that we did in pink, is here, here, and here. So that's going to be, these two are going to be stacked on top of each other, and then another one on the bottom. And then the side view is the opposite direction, so these two are stacked on top of each other and that one is next to it. Alright, on letter C, we're going to try top, front, and side view. So the top view is just backwards of B, so it's still in a V shape. The front view is 2 and 1, and the side view are these 3, so that's 2 and 1. On letter D, the top view is a square because it's like that. The front view is a stack of 2 and then 1 next to it. And finally, the side view is a stack of 2 and 1 next to it in the opposite direction. Alright, looking at E, F, and G, I'm going to have you try the top, front, and side views. Yeah, try the top, front, and side views for each of those. We'll go over them in class tomorrow. next page, draw all of the different solids you can make by joining 4 cubes. 2 have been drawn for you, and the cubes must be joined on faces, not on edges only. Translations, reflections, and rotations do not count. See how many you can come up with. Because you could do, don't worry if you have trouble drawing them in this dot paper, but you could do 4 in a row. And it would look like, not like that. I have trouble on this 3D thing too. I guess you don't see this side, but you do see this side. I don't know. You get the idea. It doesn't have to be perfect. But see how many you can come up with. Now, the question, do all the solids have the same surface area? Well, let's take a look at what we've got. This square one has a surface area of 1, 2, 3, 4 on the top, 4 on the bottom, and 2 on 4 sides. So 4 on the top, 4 on the bottom, 1, 2, 3, 4, 5, 6, 7, 8. So it has a surface area of 16 square units. The one that's 4 long has a surface area of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 square units. So no, they don't all have the same surface area. And we know that because we count the sides. But do they all have the same volume? Well, this one has a volume of 4 blocks, this one has a volume of 4 blocks, and this one has a volume of 4 blocks. So, yes, they all have the same volume. So they all can hold the same amount, but they all have different surface areas. Alright, in your own words, how can you draw a 3-dimensional figure? Draw and shade 2 prisms that have the same volume but different surface areas. So, to draw 3-dimensional figures, see if you can put into words a few steps of how to draw a 3D shape. And then, can you draw and shade 2 prisms that have the same volume but different surface areas? So we talked about ways to do that, i.e., the same number of blocks, just a different configuration so that they have a different surface area. So go ahead and draw 2 prisms with the same volume and different surface areas. And then I included this because it's interesting than anything else. Escher was an artist who was popular in the 50s and 60s and 70s, and he drew optical illusions. So you can see, I think it's easier to see on your paper than it is on my video, but all of these guys look like they're walking up, but then, or they all look like they're going down, down, down. But how could that be possible? At some point, the stairs have to get to the highest point, right? So the optical illusion is here in the stairs. They are a continuous loop, which we know isn't possible because stairs are going up. So there's no way for them to have met. And then the cartoon. The cartoon is, again, that same Escher optical illusion. So he's falling down and down and down. And it looks like down and down and down, 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 down. And he's never going to be able to get up again because he's just going to continue on this downward path. A three-dimensional figure, just to put a little definition out there, a three-dimensional figure is a solid with length, width, and depth. A polyhedron is a 3D figure with faces that are all polygons. And I have listed the definitions for you. So prisms are polyhedrons that have two parallel identical bases. So in this case, this would be a triangular prism. Those are the two bases. Even though they're not the floor and the ceiling, those are the bases because they have the same shape. Okay? The lateral faces are parallelograms, so they're all rectangular in shape, but parallelograms. Pyramids have one base. It's either a square or a rectangle, and then all of the other faces are triangles. A cylinder is the same as a prism. It just has circles for bases, so it's given this special name. And then we'll talk a lot more about this, but this lateral surface that you see here, like the part that might be the label on a can or something, is actually a rectangle if you flatten it out. And a cone is a solid that has one circular base and one vertex. Alright, so you had to go ahead and answer this question in your own words. Draw two prisms with the same volume and different surface areas. And then you had to do top, side, and front views of E, F, and G. And we'll go over this in class tomorrow. Have a great night.